Hello, welcome to embedded.com. Today's video, I'm going to show you how linked list works. So first, what is linked list? Linked list is a linear data structure where each element is a separate object, and each object is pointed to the next reference node, and the last node has a reference to null. So let's get started. So here I'm using structure node with val variable which is type integer, and then variable next which is type struct node, and I declare global variable called head which is pointed to the first node. So here I have a recursive push node. So what it does, if you pass the node here and if it is equal to null, then it will allocate the size of the node. Otherwise, pass the next reference node, and then after that, after the node is created from this function, you have to assign it to the um, next of the current node. Now push function simply um, checking the head. If the head is null, then create or allocate the node. Otherwise, check the or pass the head next reference. So you have to pass the value, and then this push function is calling the recursive push underscore node function. Now let's go to the delete node recursive function. Delete underscore node recursive function, what it does, when you pass the node in this function, it will check if the node is not null. If it is not null, then check the value. For example, I want to delete the fourth node by passing the fourth value. So if the value is equivalent to the current node, then what you can do is, before you delete the node, get the next reference node and then assign it to the temporary node. Then after that, free the node, and then since this temporary variable is pointed to the next node, then you can assign it back to the node, and then after that, return the node from this function. So it's just like when you call the recursive function, pass the next node. So inside the node, if it is deleted, then get the next reference node and assign to the from this current node the next reference. Then the fourth function is delete. Delete simply pass the val and then call the recursive delete underscore node function, and then you have to pass the head which is pointed to the first node, and then it will do the recursive function, and then display will display all the value from the nodes. Destroy node is also a recursive function. What it does, if the node is not equal to null, then get the next reference node until it reaches the end, and then until this function is false, then it will finish calling destroy underscore node, and then you can free the node. Destroy simply call the recursive node destroy underscore node function and pass the head. Okay. Let's try to run the application. So this function will display 1, 2, 3, 4, 5. Okay. Now if you want to delete the fourth node, simply use delete and then 4. So at this time, it will display 1, 2, 3, 5. 1, 2, 3, 5. Okay, now let's debug. Now first call the push function. Now we all know that the head is null. Then it will allocate the size of the node. Then make sure that the next is the next is assigned with the null value, and the 4 the 1 should be assigned to the val variable of the first node or the head node. So now, so we have head here, which is first node, and the next is pointed to the, and the next has a null reference. Okay. Now the second push. Now at this point, head is not null anymore, so it will not go here. Instead, we need to pass the next reference of the head node, which is actually null. Now here, now we are calling the recursive function here. So if the node is null, then allocate the size of the node, and then make sure that null is assigned to the next reference, and then 2 is assigned to the um, second node. Then you have to pass the allocated node from this function. Then after you assign it, when it comes in this function, the allocated node from this push node, it will be assigned to the next reference. So here you will see this next is going to point to the second node. See that? There's a lot of implementation of linked list, so I prefer to use this one, where when you call the function, you have to always return the value and then assign it to the next variable of the current node. So we'll skip the third, fourth, and fifth push because it does the same thing. Now let's debug the delete function. Delete function, simply call the delete underscore node recursive function, where you have to pass the head and then the val. Now we're going to look for the fourth node. So when you call the delete function, now we are in the recursive functions. So node is not null. So if it is not null, then we'll check if this node is the one that we are going to delete. Is this node is the fourth node? Since it's not equal to fourth node, then we'll go to the next reference of this current node, of the first node. Now we are now in the first node. If the second node is the fourth node, no, then we'll check again the next reference of the second node. So the same thing, we'll check the reference of the third node. What is the third reference node? Is actually the fourth node. Now, since it is equivalent to the fourth node, then we're going to create temporary node. Okay. So we are going to delete this fourth node. Okay. So first, before you free this node, you have to create temporary. You have to create temporary node, which is the um, um, So what you call this one? Replica, or it's a it's a, it's a clone of the next node, of the next reference node of this node. So the temporary node, it's exactly the same from the next reference node of this node. So for example, this node has a value 4. So when you assign this node next to the temporary, so this node temporary is exactly the same from the from this node. After you execute this line, then you can go to the next line, which is free node, and then after that assign the temporary node to the current node that you free. Let's go back to the code. Okay, so the fourth node is pointing to the fifth node, is it? So this is the fourth node, and it's pointing to the fifth node. So what we can do is get the next reference of the fourth node, which is the fifth node, and assign to the temporary node. So now the temporary node is pointed to the fifth node. Now we can see the fourth node. Okay, now this node is free. So what we can do is the temporary node, which is the fifth node, is now going to assign to the which was previously the fourth node. Okay, so the fourth node now is now the fifth node. So if you're going to check this one, the fourth node, 1, 2, 3, 4, the fourth node is now deleted, and then we're going to replace this fourth node with the fifth node. Okay, now you have to return the node from this recursive function. Okay, now we are in the fourth. Is it fourth? Yeah, we are now in the third node, and the third node next reference should be pointed to the fifth node. Okay, now the third node, if you look at this watch table, the third node the third node has a reference to the fifth node because we deleted the fourth node. Okay, if you're going to display, it will display 1, 2, 3, 5. 1, 2, 3, 5. Okay, if you like this video, please hit the like button and share this video to your friend. Thank you for watching my video, and bye for now.